Determine by inspection whether the vectors are linearly independent or linearly dependent. Justify your answer. So in part A, we got 3 vectors. Now we want to see if they are linearly dependent or linearly independent. If we look at closely, we got 2 components. That means this vector is coming from R2, okay, but R2, and we got 3 vectors, okay. So these vectors are in R2, and we know that in R2, if we have more than 2 vectors like 3 or 4, those vectors are always linearly dependent, okay. So the number of vectors are more than the number of entries which is coming from R2, so linearly dependent. So here 3 entries means coming from R3, but we got 0 vector here, and in a group whenever we have a 0 vector, the vectors are linearly dependent. So here we got only two vectors, and they are coming from R3. So in the case of only 2 vectors, if one vector is not a constant multiple of the other, then they are linearly independent. So let's see if we can get from here to here. 2 goes 6 3 times, but 1 times 3 is just 3, not -3. So this vector or this vector is not constant multiple of another. That means linearly independent. So here these are coming from R3. We got 2 vectors, and looks like 4 6, that's a 4 and 1/2, -8 and -4 is 12. Okay, 2 goes 3, 2 and 1/2. So the second vector, if we multiply second vector by 1.5 3/2, okay, 1 and 1/2, 3/2 means, then we get this vector. So this vector is in fact a constant multiple of the other, so linearly dependent.